Hi and Assalamualaikum. My name is Musa Mustaqim bin ISHAK. I'm from Faculty Computer Science and Mathematics, UiTM Kedah. I'm from Group KCS 1103J. My metric number is 2019296904.
Okay, hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad SYAFIRUL bin SAMSUDIN. I am from KCS 1103J, and also I am from Faculty Computer Science and Mathematics. Okay, my metric number is 2019-2983-94.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad SHUKRI bin AZIZ. I am from Faculty Computer Science and Mathematics from Group KCS 1103J, and my matrix number is 2019255506.
What is differentiation? Differentiation in mathematics, process of finding the derivative or rate of change of a function. In contrast to the abstract nature of the theory behind it, the practical technique of differentiation can be carried out by purely algebraic manipulation using three basic derivatives, 4 rules of operation, and a knowledge of how to manipulate functions. So there are three basic derivatives. First, algebraic function. Second, trigonometric functions, and exponential function. What is application of differentiation in related rates? Related rates involve two or more variables that hang the same time, possibly at different times. If we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is. This usually involves writing an equation relating the two variables and taking the derivatives of equation with respect to time. Why do we use differentiation? Differentiation and integration can help us solve many types of real-world problems. Derivative is applied to determine the maximum and minimum values of particular functions.
Okay, let's go through the related rate question. An ice cube in the shape of a cylinder is melting at a constant rate of 2 cm, as shown in the figure. So, the question 1. Find the surface area of the ice cube in terms of R. Question 2. Find the volume of the ice in terms of R. And the question 3. Find the rate of change of the surface area of the ice cube when the radius is 4 cm. Okay. The information given is R, which is the radius, and R plus 2 cm, which is height, and surface area of the cylinder and volume of cylinder formula. Okay. So for the question 1, find the surface area of the ice cube in terms of R. Given the radius is R cm and height is R plus 2 cm, so how we gonna solve this question? First, we need to rewrite the area of the cylinder formula from the information given. It is 2 pi r to the power of 2 plus 2 pi r h, and then we need to substitute the height to the formula and it becomes 2 pi r to the power of 2 plus 2 pi r in bracket r plus 2, and then it become 2 pi r to the power of 2 plus 2 pi r to the power of 2 plus 4 pi r, and the final answer is 4 pi r to the power of 2 plus 4 pi r. Alright, let's go to the next question. Question 2. Find the volume of the ice in terms of R. In this case, we need to make only R term into the volume of cylinder formula. So the solution is you need to rewrite the volume of cylinder formula from the information given, which is pi r to the power of 2 h, and then we need to substitute the h into the formula, which is r plus 2, and it will become pi r to the power of 2 in bracket r plus 2, and the final answer is pi r to the power of 3 plus 2 pi r to the power of 2.
Next, find the rate of change of the surface area of the ice cube when the radius is 4 cm. So, the first thing to do when getting a question like this is to find the information and write this in the form of equation that we can understand. According to the question, we can write that an ice cube is in the shape of cylinder is melting at a constant rate of 2 cm in the form of dV over dt equals to -2. It is negative because the question seems like ice cube is melting, which means its volume of radius. Another thing we can get through this question is to find the rate of the surface area of the ice cube when the radius is 4 cm. We can write it in the form of dA over dt equal to what when r equal to 4 cm. Next is, after getting the information from the question, we must know what the question wants. So the question wants to find dA over dt, and to find it is to make equation which is dA over dt equals to dA over what times what over dt, and through the information that we can get, we can write the equation of dA over dV multiplied by dV over dt. dA over dV can be separated again to find by writing the equation of dA over dt equals to dA over dr multiplied by dr over dV multiplied by dV over dt. From the equation, the value of dA over dV can be get from the differentiation of the area equation from question 1. So the value of dA over dV equals to 8 pi r plus 4 pi. Next is dV over dr can be getting by differentiation the equation of V against t, and the value of dV over dr is 3 pi r to the power of 2 plus 4 pi r. Now just replace the value in the equation of dA over dt by replacing dA over dV equals to 8 pi r plus 4 pi, dr over dV equals to 1 over 3 pi r to the power of 2 plus 4 pi r, and dr over dt with -2. After we done replacing the equation with the value that we get, the answer of dA over dt is -16 pi r plus 8 pi over 3 pi r to the power of 2 plus 4 pi r. So just replace the value of r with 4, and the final answer we will get -9 over 8 cm square second -1.
Conclusion. In conclusion, related rates problems involve finding a rate at which a quantity to other quantities whose rates of change are known. The rate of change is usually with respect to time. We can found that by applying the maximum and minimum, it has the connection with the differentiation. Derivatives are met in many engineering and science problems, especially when modeling the behavior of moving objects. There are many uses of differentiation that we can apply. First, use in history for predicting the life of a stone. Second, used to solve problems including limits. And last, used to find local maximum and local minimum.